Today on How It's Made. Gears. Leather watch bands. Vitrell dishes. And kitchen shears. If you've ever looked inside a wind-up watch or a car's transmission, you've seen a system of gears. A gear is a wheel with teeth that meshes with the teeth of another gear to transmit power on a continuous basis. Combining gears of different diameters affects rotation speed and force. This factory makes gears that go into transmissions for industrial machines. Production begins with a large round bar of high-grade steel, which contains a certain amount of carbon to make it even stronger. An automated bandsaw slices off a piece that's the right thickness for the size of gear they're making. This piece is called a gear blank. They mount the blank on a computer-controlled lathe. As it spins, a turret carrying a series of carbide tools moves in. One tool after another takes its turn machining the blank to a specific shape. A shower of coolant prevents overheating when the jumbo drill has its turn. It bores a hole right through the middle of the blank. The last tool carves a groove on the front of the blank. This final bit of metal removal lessens the gear's weight. Now the blank goes into a computer-controlled mill. The mill drills holes through which lubrication will flow when the gear is operating. These holes also lighten the gear's weight. When the blank comes off the mill, they stamp it with the company name and part number. Now for the gear's teeth. A machine called a gear shaper carves out the inner teeth, the ones lining the center hole, with its titanium-coated cutter. The machine's other components keep the cutter's movement correctly timed. The number of teeth and tooth size vary from gear to gear, so for each model, the factory has to fit the gear shaper with a specific cutter. Now for the outside gear teeth. The computer-controlled machine that cuts them is called a gear hopper. The gear turns against it as it cuts. If the hopper would cut the full depth of the teeth in one shot, the cutter would chip. So the gear keeps turning around and around again as the hopper cuts a bit more with each pass until the teeth are the right depth. Then the gear undergoes a computerized inspection. A probe scans the entire surface, including every tooth. It sends data to a computer which then analyzes the dimensions and ensures they meet the engineering specifications. Gears that pass this quality control inspection go into a furnace for heat treatment. This strengthens the steel. When the furnace reaches a certain temperature, they inject carbon inside. The gears absorb it, and the steel strengthens even further. A soaking in oil afterward hardens the metal. Heat treatment, however, distorts steel somewhat, so each gear now goes to a computer-controlled grinder. It restores them to very precise specifications for bearings to fit properly. This factory manufactures gears in various sizes, and not only in steel. It also makes gears in materials such as nylon, aluminum, brass, and stainless steel. Some gears have straight teeth, others angled teeth, which makes less noise when turning. Gears are an essential component in everything from watches to heavy mining equipment, keeping machinery going at every turn. When it comes to wristwatches, there's nothing quite like a band made of genuine leather. It has a classic look that's versatile, working with both casual and formal attire. And a leather watch band is always comfortable against the skin, because unlike synthetics, leather breathes. These premium watch bands are made of alligator, a leather with an unmistakable texture and shine. The tannery dyes the croc leathers in classic shades, as well as in the latest high-fashion colors and styles. Nearly all the production steps are manual, beginning with cutting leather pieces for the band's two straps. Every watch band model requires a steel cutter for each strap in every size. Now they coat the backside of each piece with glue. Later, when it's almost dry, they center a watch band core onto it. This flexible form is made of synthetic material reinforced with fiberglass. Using a machine with a fine blade, they make small cuts at the ends to let the leather fold smoothly over the form. One side of each strap attaches to the watch face with a spring-loaded bar. They mark exactly where the bar goes, then punch a tiny hole for its tiny base. Next, they apply super-strength glue and fold the leather over to encase the bar. The glue dries instantly. They now coat the rest of the form with glue, then lay it in a mold that pushes the leather against the edge tightly, so they can neatly fold over the remainder. Now they run the open end through a machine that cuts a beveled edge. Next, they run a tiny sander over the leather on the backside. This roughens the surface, which will help the leather backing adhere. To make the loops which go on the buckle strap, they bevel the ends of small leather strips. They glue and fold them into a loop, making sure they're large enough to fit around both straps. One loop sits directly below the buckle. A glued-over flap of leather locks it in position. They press it flat with pliers to ensure a good bond. They machine stitch each strap with strong polyethylene-based thread. To prevent unraveling, they melt them right into the leather. On the buckle end, they pierce two holes for stitches that reinforce the locked-in first loop. Then they punch two holes in the back of the second loop for stitching to reinforce its glued-together ends. This loop has to be movable, so they don't stitch it to the band. They heat the edge of each strap. The iron's rounded tip molds an attractive rounded edge. Using a heated tool again, they widen the channel through which the buckle will pass. Now they insert the buckle end into a stamping press. It cuts a slot for the buckle's tongue. A heat press burns the company's name into the leather lining. That same strap then goes into a press which punches the sizing holes. From here, both straps go off to the buckle department. Random samples are subjected to rigorous quality control testing. This machine pulls the ends of the strap in opposite directions with up to nearly 50 pounds of tension, far more than anyone would ever apply to the watch band when they pull to buckle it. Vitrel is a super durable dinnerware material invented in the United States in the early 1970s. It's made of 3 layers of glass fused together. Vitrel dishes are thin and lightweight, yet they're stronger and far more break-resistant than ordinary dinnerware. In a perfect union of form, function, and food, this company serves up Vitrel dinnerware in several striking designs. The dishes are made of 65% recycled glass from earlier production runs. To make the other 35% that's new glass, the factory combines several raw materials: sand, salt, limestone, feldspar, and 2 more types of salt. The exact proportions are a closely guarded secret. The ingredients go into a furnace, where a fiery 2,500 degrees Fahrenheit melts them into liquid glass. It exits the furnace. An extruder shapes it into a 3-ply sheet that lands in a mold, in this case, a plate mold. A trimmer cuts off the excess, while compressed air blows down from above to cool and solidify the glass. A vacuum arm then extracts each dish, and the leftovers are recycled. The dishes now undergo what's called fire polishing. Each one passes through a gas-oxygen flame, which seals the 3 layers of glass. It also melts the outer rim, smoothing and rounding out the rough edge created by the trimming. Oval dishes go on a different fire polisher, designed for an oval rim rather than a round one. Now the conveyor system flips each dish over for backstamping. The bottom of every Vitrel dish has the trade name and other information. A silkscreen machine applies the lettering. Then a gas air flame bakes the ink into the glass. Once that's done, the conveyor system flips the dishes right side up again. To decorate the dishes, a machine silk screens the design onto membranes. Robotic arms position a membrane above each dish. Then, a press head pushes the membrane down onto the surface, transferring the paint. Robotic arms then move the dishes back onto a conveyor belt. Certain dishes have a design on the outside. An automated silkscreen machine applies the paint directly to the surface. The decorated dishes now travel through a tunnel oven for 5.5 minutes. The nearly 1,500 degree Fahrenheit heat cures the enamel paint. At the end of the ride, a tempering process that makes the glass stronger. Then, nozzle spray the dishes in a soy-based silicone. This wash-off coating prevents scratches during packaging. The factory subjects a sample from each production run to a 6.5-foot drop test and a rim impact test. The sample mustn't break, chip, or crack. All to ensure this stylish dinnerware will withstand whatever your household can dish out. Shears are typically larger than scissors for heavier duty cutting. And you can insert up to 3 fingers in the handle's finger ring. Using more fingers gives you a stronger grasp, which translates into more control and more cutting force. These high-end shears effortlessly slice through produce, snip fresh herbs, and open packaging. Outside the kitchen, they easily cut many materials, including thin aluminum and galvanized steel. The secret to their strength? Blades made of stainless steel, which contains a minute amount of carbon. To make them, workers feed a bar of this high-carbon stainless steel into a press. It stamps out blade shapes called blanks. Stainless steel can be heat-treated to make it more durable and corrosion-resistant. But first, a furnace softens the blanks for the forging process that transforms them into blades. Each blank goes onto a forging die that has 2 blade-shaped cavities. 1 strike in each, and the blank is a blade. Once it cools, a trimming press cuts off all the excess metal around the perimeter. Heating and forging tend to warp steel, so another press makes the blade perfectly flat and straight again. Trimming the excess metal leaves some rough areas, so the next step is to smooth the surface with a sanding belt. To make the hole for the bolt on which the blades pivot, they drill a round hole partway through. Then pierce a rectangular hole through the rest. You'll see why later on. Now the blades undergo heat treatment. First, to harden them, a slow heating and rapid cooling. Then, to make them tough and durable, a reheat and slow cooling. A grinder shapes the round area next to the tang, the term for the metal core of the handle. With a sanding belt, they smooth out and blend the adjacent corners. Here, 2 polishing wheels give the surface an upscale satin finish. Then an etching machine uses electrically activated chemicals to imprint the company's name into the thumb-operated blade. Just one final step before the blades are finished. A computer-operated grinder serrates the inside edge of the thumb-operated blade. Workers now load 6 blades at a time into an injection molding machine. The machine shoots molten plastic into the cavities, then rapidly cools the material until it solidifies. Each blade exits the machine with a molded handle firmly encasing the tang. Now for the final assembly. First, they drive a bolt with a rectangular head into the pivot hole of the finger-operated blade. Then they add the thumb-operated blade and press the bolt again into its final position. A self-locking hexagonal nut secures the bolt from underneath. An automatic tightener does the initial fastening. Then, workers do the final tension adjustment manually. The final step is to grind the excess plastic off the handle stops. This enables the blade to close fully and in perfect alignment. So why the rectangular bolt? Watch closely. It allows you, with just one simple twist, to separate the blades for cleaning, and then reassemble them. Now that's cutting-edge design.